Hello, I'm Quick Wingissa. Welcome to today's webinar on what it takes to be battery ready. So this is the second in a four-part series of webinars that we're hosting every Wednesday from now through February 8th at 10 a.m. The idea for the webinar came out of the presentations that Harrison Sloan was actually giving last year. Last year, we were on tour providing information to clients and consultants about preparing for this year's 2022 Energy Code update. And after each of those presentations, people would come to us with questions and comments. Over the months, we collected them and started to see that a lot of things were repeating. So what we decided to do was to take those questions and form a series of webinars around them where we could, in a short 30-minute session, provide that information to the broader building community. Today in particular, we're talking about what does it take to be battery ready. We can't really talk about battery readiness without talking about electrification. Now, electrification is part of the trend towards removing gas appliances from all of our buildings. It aligns with state and national goals of reducing greenhouse gas production overall and has been implemented as part of the 2022 Energy Code, building code updates. Additionally, this code cycle, there are many more jurisdictions that have local ordinances that are banning the installation of new gas lines to residences. And as our home buyers become more environmentally conscious, more of them are asking that, we produce electric ready and electrified homes. So it's become a selling point for our clients. Now we expect these trends to continue with each subsequent code cycle. And as such, it's important that, the designs we're putting together have been future-proofed as much as possible so that today's home buyers are going to be satisfied with their purchase 3, 6, 10, and more years into the future. Now, looking specifically at battery readiness. Battery readiness is a part of a trend towards removing gas appliances from all of our buildings. It aligns with state and national goals of reducing greenhouse gas production emission and has been implemented as part of the 2022 building code updates. Additionally, as home buyers are becoming more environmentally conscious, having a battery-ready or electrified home has become a selling point for our clients. And we expect these trends to continue with each subsequent code cycle. And as such, it's important that our designs have been future-proofed so that today's home buyers are going to be satisfied with their purchases 3, 6, 10, and more years down the road. Now, I'm being a little cheeky here and repeating myself, but the point that I want to hammer home is that battery readiness and electrification really go hand in hand, right? What happens is that as we electrify more and more buildings, we exacerbate what's known as the duck curve. What happens is that every morning around 6 and 7 o'clock, when people wake up, start taking a shower, cooking breakfast, and then again in the evening around 6, 7, 8 p.m., people are getting home, they're turning on the TV, again, they're making meals. We experience our peak energy demand, but this doesn't align with the peak production of renewable energy sources. So our energy providers fire up their quickest acting, but also their most gas inefficient and greenhouse gas producing power plants, right? So as we electrify more homes, the CEC and other agencies see that we have to put together technologies that allow us to offset that peak energy production to better match with the peak demand. Having battery ready homes is one step in that direction. Now, battery readiness is mandatory for single family homes, including R3 townhomes, right? So that's going to be the focus of this presentation. Battery readiness is not mandatory for low-rise multifamily, including R2 townhomes. And battery standard, right, installing batteries is actually, it's not required, but in practice, it's what is required for high-rise residential buildings. Again, though, remember that this presentation that I'm giving today is focused specifically on single family, including R3 townhomes. So there's specific code language that explains, this is the code language that explains what battery readiness looks like. We've actually taken that and distilled it into an image and giving you the Spark notes here. So the first piece is that you're required to have a 225 amp bus bar. This corresponds with the 200 amp service that we're all already used to installing in our homes. You're also required to create a space for battery interconnection and equipment within 3 feet of the main panel. So that's shown here. Thirdly, you have to have a sub-panel, and you have to select at least 4, and they specify which 4 circuits, to be co-located. Essentially means the wiring has to at least go behind this panel. And last, you have to install a 1-inch raceway that allows you to connect this sub-panel to the main panel. Now, these requirements, first off, they're a little bit behind the times, right? Since the CEC put together this language several years ago, a lot of builders have actually started installing sub-panels and don't need the raceway. Unfortunately, right, this was kind of our first red flag. The requirements say that these must be met. There are no exceptions, right? So that's one problem that we immediately saw with the code language. Another issue that we saw is that this doesn't mention anything about the actual battery. Right? This space here is interconnection equipment. That is not the same as the actual battery. That's a whole separate piece of equipment, and space needs to be set aside for that. Additionally, it doesn't mention anything about the solar PV system. As I explained earlier, solar PV and battery systems really go hand in hand, so it's important to make sure that your solar PV can tie into your battery system. So really, the problems that we're seeing are twofold, but it comes down to a question of coordination. We're seeing that if you only do the minimum here, your homeowner is probably not going to be satisfied with their purchase, because when they come to install a battery into their relatively new home, they may find that they don't have the space for it. They have to tear out drywall. They have to run fresh electric wires that they weren't expecting. The other thing, again, is that current construction practice has already moved beyond this. Now, our team, Harrison Sloan, has spent the past year talking with the CEC, talking with solar designers, with electricians, and more importantly, talking with builders who are installing batteries in their homes right now, in order to better understand what is required to make sure that we're prepared for a future installation. From these conversations, we produced some language and diagrams that we provided to the CEC, who communicated back to us that they will release official documentation saying that our recommendations are permissible. And again, this is critical because the language is so strict, right? We had to make sure that we carve out a space for common standard construction practices to be allowed. So here is our recommendations in diagram and a schematic layout, as well as some notes on essentially additional design parameters. Now, the first thing you'll see is that this takes up a lot more space, right? This 8 to 10 feet of wall space, right, compared to the 4 or so feet in the CEC minimum diagram. And again, I can't stress enough how important it is that we coordinate this early, because this 10 feet of space is before you consider any other discipline, right? There's going to be a fire riser somewhere on this wall. There's probably going to be a water heater. There'll probably be a gas line somewhere, and that all needs to be coordinated, right? And if you don't plan it ahead of time, somebody's going to encroach upon the space and it won't really feel battery ready. So the big piece that's taking up more space, of course, is the battery itself. These things are fairly wide and fairly deep. We've found that typically installing it towards the front end of the garage near the big garage door is our best choice. You can install it on the exterior of the home, but there's questions of potential theft. And then if you were to install it somewhere else in the garage, particularly if it ends up in the potential line of travel of a vehicle, then it's going to need some protection, i.e. bollards. Again, this is something for your design team to coordinate early as the project is being developed. This is just a recommendation and a schematic layout. Another thing that we've added in the schematic layout is integrating solar, right? Recommend that your solar wiring also passes behind the battery interconnect, the space that's been set aside for the battery interconnection. This is because, again, solar and battery are integral. We want our homeowner, should they install a battery system, to be able to maximize their net energy metering And also in the case where, PG&E shuts off your power during a hot high wind day, we want to be able to charge up that battery during our peak PV production. Lastly, our design really incorporates the current standard building practices. What we found is that most builders are already installing a sub panel, and by taking advantage of it, that's one less change to a contractor's work, and it's one less thing for the builder to pay for, right? We can co-locate quite a lot of circuits we found in this sub panel without exceeding what a future battery would potentially be able to handle. And I'll talk more about those specific circuits in a future slide. The last piece is this wire here that's connecting the main panel to the sub panel. We recommend a 70 amp cable, and we recommend adding in a loop here, right? This loop allows you to integrate the sub panel with the future battery system. And when you look at our overall design, this is actually the only new piece of equipment that we're asking be installed. It's this extra wire in the space. Everything else is either already part of the standard construction practices or is a matter of coordinating and planning. So again, if you forget all the details that I've gone through here, just remember that coordination is key, right? We have a lot of overlap. We have a lot of space that this is going to take up in the wall, and we have to make sure this doesn't conflict with other disciplines. But we also have overlapping scopes of work, right? So we want to make sure nothing falls between the cracks. If we start with this situation over here, right, with the electrician pointing to the solar designer, right, asking, aren't you in charge of battery ready? Solar designer points to, the future battery installer, and they also point to us at T24 saying, well, the requirements in T24, right? What we'll end up with is things falling between the cracks and really, ending up with a design where a home buyer may have to do a, what feels like a garage remodel in order to install a battery system. And ultimately, the only thing they're going to see is here, the builder. So the last piece before we start wrapping up here is, I've been talking a bit about how we can make sure that our designs reasonably meet battery ready expectations, but the other side of that coin is making sure that we are setting up the buyer's expectations properly, right? The future battery system is not a whole home backup. It can function as a partial backup. What it's really going to do is it's going to maximize the home's net energy metering benefits, right? So the homeowner is going to see the biggest drop in their electric bill, really. We found that the sub panel, and therefore the future battery system, is probably going to be able to accommodate about a dozen 15 to 20 amp circuits, right? Now, 15 to 20 amp circuits, that's most of these right here in green. What it's not going to be able to handle is your clothes dryer, your water heater, your air handler, your oven range. Again, this is something to more specifically discuss with your electrician as you're going through the project, but we do want to make sure that we're setting the buyer's expectations reasonably. Now we're going to wrap up with a few pictures of actual installations, and then we'll open it up to Q&A, all right? So here's a picture of a wall that's still opened up. We haven't put drywall here. This is actually a home that's going to be battery standard, but what I want to draw your attention to is over here, we've got our sub panel, and over here we have our main panel. And here's the wire that connects the two. All of this so far is pretty standard in your home. The new piece is actually this section of loop here, right? This is the only additional piece of equipment in our recommendations that you're probably not already installing in your home, right? The rest of it is all coordination. And, I want to stress it again, because once you put the drywall in, you're not going to see a lot, right? If you walk into the garage of a home that's battery ready, you'll see the sub panel, pretty standard. You'll see the solar junction box, also already standard. You'll see this little access panel, which isn't standard, but it doesn't look like much. But if you took an X-ray machine that also looked, a few years into the future, you're going to see that there's a lot more going on in here, right? You've got this space here that has been left clear for a battery. You've got this little wire here behind the wall so that this other space that's been left clear for the battery interconnection equipment will be easily accessible for them to connect it. And then on the back side, on the other side of the wall, you'll see that there's your main panel there. Almost more important, though, than what you see here is what you don't see, right? You're not going to see a fire riser. You're going to see that there's enough space over here, right, between this electric vehicle charging station and the sub panel for the battery. You're going to see that there isn't a water heater. You're going to see the edge of the door, but only the edge of the door because the door is shifted far enough to the side to not interfere with this, right? Again, if you forget everything else here, remember, you don't need to spend a lot of money, but what you do need to do is make sure the people are putting on their thinking hats and not letting things fall between the cracks in terms of design coordination. Now I'll turn it over to y'all for Q&A. We've got a question here for Dallas Brown. Has there been a discussion about the approach for alley-loaded detached townhomes, where garages may be opposite end of homes from meters? With regards to Dallas, can you kind of expand on that question?
Sure. I'm talking about like an alley loaded home where your front door is on one end of the lot and your garage is on the other end of the lot,
Mm-hmm.
but your meters may be at the front door or on the home side. Your point of connection.
Sorry, I'm having an issue kind of imagining this in my mind here. Are you able to provide like a picture, or Ravi, do you have an answer in your mind right now?
It sounds like a
I think
similar
this,
situation.
yeah, I think this is the same question Leilani asked. In a condo situation or an alley loaded, your meter is physically separate from your garage by like all the way through the house or even through a building common area.
Okay.
Yeah, in this case, I'm similar. Yeah, but in this case, I'm talking about a detached home that just happens to the garage is on the alley and the front door is on a street. But yeah, the separation similar.
So single family home, I see what you're saying. I don't think we've considered that option exactly. We could take a look at it, but ultimately, you would still need to be within the ESS device would still need to be within 3 feet of that main panel. So you would end up kind of putting that near the main panel within 3 feet. So it would, go outside. But we can take a look further into the code and see if there's, likely at this point there's no exception, but we'll dig into it and see if we can find an alternate rather than having the batteries or the ESS device mounted on the exterior.
Yeah, Dallas, if you could follow up with us, and maybe provide an image, that would probably make it easiest for us to take a look at it and put some information together.
I can do that. Thank you.
Perfect. John Gross asks, PG&E has informed us that solar combiner box cannot be installed between the main meter and gas meter. Need to make sure this is reflected on solar plans. Again, this is a part of why kind of we're having this conversation, because there's a lot going on in that wall, and if PG&E is telling you can't put the solar combiner between the gas and the main meter, we need to make sure that that gas meter is kept out of the space where we're putting together the battery ready elements of the design. I'm not sure if that's like a question or more in terms of information, John.
Yeah, more of information.
Thank you. Appreciate it. if the house is set up for partial solar backup and the homeowner wants to update to a full battery backup, do the breakers in the sub panel need to be changed? That's a good question. So I think this is one thing that I didn't touch on, but I definitely it's important to note that in general in these systems we're talking about, in this presentation we've been talking about battery ready designs. In the case where you're either optioning a battery for the community or doing something other than simply battery ready design, this is a starting point, but again, you're going to have to discuss with your team to make sure that you're setting up the system that makes the most sense to make sure that you can integrate the battery standard design into what you're doing in your homes. In terms of updating to a full battery backup, theoretically, I mean, I think that's kind of a bigger question to ask right now. I don't know that anybody's really doing like a full battery system, right? This would require more than what the typical batteries on the market right now are capable of supplying.
Quaker, this is Abe. We've got some. There's some communities out there that are starting to consider doing battery standard. Actually, there's some communities out in Sacramento area that are doing battery as standard, and offering as and another community that's doing it as an option. And what they have done is, yeah, they are in that sub panel. They're putting a space for those breakers. So should the homeowner decide to include a battery, an option for a battery, it's already kind of set up. So they got the infrastructure set up there. That in our design that we are proposing here, we would do the same. We would have that space available, essentially. If you were to incorporate a battery at a future date, it would just have to run on the surface and then connect up into that sub panel at some point. So that's ultimately all we can do at the moment. This is a great example of the fact that this is an example of the code kind of moving in this direction and leaving it up to the building community to kind of decide the best measures and the proper way to kind of format it. So in other words, they don't get into the details. It's kind of our responsibility to do that. So that's what we're doing. Well, this is the start of it right now. So.
John, does that answer your question?
Yeah, I think so. I mean, the communities I'm working on, we're planning on doing the battery backup as a standard.
Mm-hmm.
And then, but as you mentioned, earlier about, the buyer wanting to go in and then adding to that and maximizing it, is it going to be possible for them?
Yeah, that would be something to talk with your design team about more in depth. Again, at the moment, kind of with what we're seeing available on the market, most systems simply aren't going to be able to, meet that ideal of a whole home backup without some serious investment.
If I can jump in real quick with the John, we got to talk in terms of cost effectiveness. And if we just put our blinders on cost effectiveness right now, I think the solar community is doing a great job of kind of addressing the need to add batteries. It's something that, 2 years ago, we weren't able to give them the option of leasing it and incorporating it into our solar systems. And now it's a potential. And it's actually, I think there's some good options from many of the major players out there to incorporate batteries into the system, and builders can take advantage of that. But it's only cost effective from a one battery standpoint. We haven't been able to make two work. But your question related to adding another battery, I would that's where Kwaku is correct in terms of making sure that whatever the battery controllers that they're incorporating right now, I think with some massaging could work on with two. I think that's not what the intent of the market is currently, because I think everybody's trying to make the one battery work. Jumping to two obviously is a kind of that'd be a sweet situation. Then we could possibly address most or not all the loads potentially. But just trying to, it's just one of those things where we're out of the gate right now, and innovating to two batteries right now is not the primary focus at the moment, as you can imagine. It's just trying to see if we can even get ready for them properly. is where we're at. But your questions are fantastic. We certainly would love to see communities where the homes are all backed up. But just trying to give us the situation that really is. That's where we're at right now.
All right. Jumping up here, looks like I missed a question. What is the minimum wall length needed? I mean, really, that depends on what you're putting together. But our schematic, from what we're looking at, you're going to need 8 to 10 feet of wall space for to include the battery system, the main panel, the sub panel, the solar and the battery interconnect. And then let's see, Mike Fuller. Have you had any discussions with cities about clear garage space requirements and the potential for the solar battery to project into the required clear spaces? That's kind of where we got to in terms of looking at this sort of setup. Right over here, we've got the battery located near the front end of the garage, kind of by this garage wall. That way, even if it's jutting out, it's still sort of protected by the by that short wall where the garage door roll up is. If you place it in other locations, again, you have to work with your architect, work with the jurisdiction to see what their requirements are going to be. Generally speaking, if the battery is going to be in the space where a vehicle could potentially hit it, you're going to need to add in some bollards or some type of protection there. Okay, got it. In terms of clear floor space, yeah, I've heard some different things about it. Again, that is also something to talk with your jurisdiction about. I've heard some allowing it to kind of protrude into that clear floor space. But again, you'd have to talk specifically with your architect and with the jurisdiction to see what they will or won't allow.
At Quaco, this is John Gross.
Yep.
Every jurisdiction I've contacted thus far, that requires the minimum of 20-foot width in the garage hasn't considered the battery on the wall to be intruding into that space, and they are allowing it. But you have to check every jurisdiction. So.
Yep. All right. Thank you, John. Appreciate that. All right. So just to wrap up here, thanks for joining us here today for this webinar. Again, in terms of what it takes to be battery storage ready, what we want you to leave this presentation with is buyer education is critical, right? In order for us to make sure we're setting up reasonable expectations for what our home buyers are expecting and how they want the house and how they think the house will be able to perform. Another piece that we want you to leave here with is remembering that the CEC minimum is not enough, right? Technology and our construction practices have moved beyond it, and we've set up some diagrams to help you kind of see what you can do to actually meet a practical battery-ready design. And then the last piece, of course, is that coordination early is critical. This takes up a good chunk of garage wall space. You've got a solar designer in there, you've got an electrician, you've got a future battery installer that obviously isn't in the picture. So again, we need to coordinate early and coordinate thoroughly. All right. So thanks for coming to this presentation. We've got a couple more coming up in this series. Next week, Wednesday, we'll be looking more specifically at our 200 amp panel. Is it enough for our electric ready homes? And then the following week, February 8th, we're going to look at getting everybody their incentive money for their all electric homes so that this becomes more and more cost effective. All right. If you have any other questions, any other comments, any other feedback, please reach out to us. My email and Abe Cubano's as well is on the slide here. And yes, we will be sending out a copy of the slides after the presentation, including information from the Q&A. All right. Thank you, everybody.
Thank you, Quaku.
Can I ask one more question, Quaku?
Oh, yeah, absolutely. Yeah. Yes.
We typically provide, the sub panel for the whole house. So this sub panel we would be running our backups on, would that have to be a separate panel then, just for the backups?
No. So I think that's what, I'm pretty proud of what we put together here, which is we saw that a lot of people are using this sub panel already. Simply by planning how we're going to use that sub panel, we can integrate it into the battery ready requirements so that, you don't have to install anything new. You don't really have to tell your contractor to install anything new, right? You just have to think about what circuits are actually tied into that sub panel. And then again, just add in that little extra loop of wire connecting that sub panel to the main panel.
Okay, so it'll only be certain breakers from that sub panel that'll go into the solar panel. The backups ones.
Yeah, that'll be the backup. That's the backup. The circuits that would be able to be backed up by the battery. Yes.
And that has to be, and that sub panel does have to be a certain distance away from that.
The sub panel does not have to be a certain distance away from the main breaker, but the interconnect, the space that's set aside for the interconnect, that has to be within 3 feet of your main breaker.
Of the main breaker, not the sub panel.
Yes, of the main breaker, not the sub panel.
Perfect. Thank you.
Yeah,
Absolutely.
that's a great question, John, because I just went on off site and saw 2 panels being installed. Why? Because the electrician had on his scope of work to install a sub panel, and the solar guy had on his scope of work to have a solar panel. And guess what happened to that garage wall? They had 2 separate solar panels. When they had coordinated, they would have realized that they could have, put most of the circuits in all those circuits in one panel. But that's kind of the primary reason why, well, one of the reasons why we wanted to get all of us together and relay this information and get to that. But great questions, John. I appreciate it.
Hey, John, to add clarification to what you were asking, I just want to make sure we said this right or answered the question correctly. Every circuit that's on that sub panel would be backed up by the battery. You can't parse them out. So whatever's in that sub panel has to be sized to work for the battery, were you to add the battery, and they're all going in there. There will be situations where you'll need 2 sub panels based on the size of the house. So if you're getting into a 4,000 square foot house with an in-law suite, with some other stuff like that, you're not going to have enough room on that single sub panel to put all of your circuits. And then at that point, you can either move the remaining circuits to the main panel if there's room, or to a second sub panel if there's room. So there's some stuff there that needs to be kind of coordinated as you get to a certain size of house. So like Quaku said, working back with the design team whenever possible. Luckily for you and your team, we are working on those projects. So hopefully we're pointing you in the right direction as we go.
Okay, so mainly your water heater, your heat pump, your house and everything, those breakers would all be in the main panel and not the sub panel.
Correct.
Correct.
Essentially, anything that's over 20 amps really isn't going to be able to be powered by your battery, and it will need to go in the main breaker. All right, one more question here. Leilani asks, could the backup battery be located in the attic? For instance, if the attic is directly above the garage. Avi, have you seen anything with this?
Probably not, just for, I mean, it is, I guess it could be accessible, but yeah, we wouldn't recommend it. But it's hard to say if it's actually doable, but I mean, I would probably keep it within, a certain distance from the unit panel and everything else. And also just to maintain, clearance for it, and it could be serviced easily if needed.
Yeah, when we were checking into solar, I asked that question, and also I asked if it could be mounted on the ceiling of the garage, versus so it would be out of the path of travel. And both of those was a negative.
Yeah. We're blazing new trails here, so.
Awesome. All right. Great. Well, thank you, everybody. Again, if you have any more questions, any comments, any other help that you need, please reach out to us. We will be happy to try to address those answers for you. And then Dallas and Leilani, if you wanted to send us pictures about your questions, that's something we can also take a look at and send you some feedback from what we see. All right. Thanks, everybody.